Welcome everyone. Now we are moving the previous year objective question session 2 for the CBSE 2023-24. For class 12 physics, I'm just taking the chapter number 7 for the revision part. Now the first question, these questions are with the topic instantaneous, peak, RMS and average value of AC. Okay. So like the first question is the RMS value of an AC of a 50 Hertz is a 10 ampere. The time taken by the alternating current in reaching from 0 to maximum value and the peak value of current will be. We have an option. So, just see the solution part. कैसे से solve करेंगे? So, t is equals to, we know that t by 4. If I'm just taking the value of a time period, what you have to what is the key point will be there. This key point is the time taken by the alternating current to reaches from a 0 to maximum value and the peak value, and for that time duration t is equals to t by 4. So taking this particular terms, we know that time period is equals to 1 by of a frequency. We know that in our home 50 hertz frequency will be there with the 10 ampere. So from here we get the value for time, and for the value of peak value for current, that is a root 2 times the IRMS. So from here we get the value. According to this, the correct answer for this question is option 4. I hope you understand this part. Moving ahead with this new question, the form factor of for AC, a sinusoidal AC is 2 root 2 ratio pi, pi ratio 2 root 2, root 2 ratio 1, or a 1 ratio root 2. The form factor of a sinusoidal AC is. So, the solution part, form factor means RMS value and the average value over a half cycle. So, RMS value we know that is I naught by root 2 and the average value 2 I naught by pi. Students, that thing I think you should know. The value of a form factor of a current, so this is IRMS divided by I average. We know the value of IRMS. This is I naught by root 2 divided by, this will becomes 2 I naught by pi. So this value we can write in this particular form. I naught we can divide it over there and this value comes into the nature like pi ratio 2 root 2. So the correct answer this will be. Moving ahead with the next question. At resonance, the peak value of current in LCR series circuit is E naught by R, second E naught by R square plus omega L minus 1 by omega C whole square over the root. E naught by under root 2 and with the root R square plus omega square L minus 1 by omega square C square whole square. Fourth E naught by root 2R. If I'm just moving at the resonance or peak value of LCR series. So student, that we know for that scenario that LCR circuit, if that will be in the resonance position, so XL will be the value of equals to XC. For that scenario, Z is equals to R. So according to this, we have a result first one. Next question we have, the time taken by an AC of 50 Hz in reaching out from the 0 to its maximum value will be 0.5 second, 0.005 second, 0.05 second and a 5 second. Solution part we have, from 0 to maximum value, student please keep in mind like a 0 to maximum value time period which we will take, that is 0 to t by 4. This is the value where the current or the things will be start from 0 to maximum, as this will be taking in terms of a phi. This will be 0, this will be pi by 2, this will be pi, this will be 3 pi by 2, and this will be 2 pi. But in the terms of a t, this will be 0, t by 4, t by 2, yes, this will be 3t by 4, yes, and this will be t by 2, and this will be t, of course. So this is the peak value, or 0 to maximum. 0 to maximum for this case, this will be 0 to t by 4. That's why we are taking the time over there. I hope you understand. So for 0 to t by 4, if I'm taking the value of a t, so we know that the value of a t is 2 pi by omega, and the value of a 2 pi I'll just put, and in place of omega I can put the value of a 2 pi f. So I'll just put all these value over there. We can do directly like this. T is equals to 1 by f, so that will becomes 1 by 50 hertz. So like we just put this value over there, 1 by 50, which will be received like if I just want to place like t is equals to 1 by 50. So what we can proceed, t is equals to 1 by 50 into 4, and if I just do division part, so this will becomes 200, and when I solve this value of a t, so the answer will come 0.005. Now you have a two different method, like here I just show you another method, and you can proceed with that also. Like you just put all these value over there in the place of a t, and divide by 2 divide by 4, you get the same result. I hope you got my point. Next question we have, alternating current in the circuit is given by I is equals to I naught sine 2 pi nt. Students, please look at here. What is the I naught represented? I naught represented the peak value of a current. What is the 2 pi n represent? This is the value of omega, where we know that omega is equals to 2 pi f or 2 pi n. So we have to calculate the time by the current raised from their RMS value. So this will be the options: 1 by 2n, 1 by n, 1 by 4n, and 1 by 8n. Let's move with the solution part. So like we know the value of a TRMS. If I'm just talking about the value of a TRMS, so this will be T naught by root 2. I naught sine omega t. So instead of omega, we just using sine 2 pi nt. Just do calculation and get the result like a 1 by 8n. I hope you understand. Next question we have. A mixer of 100 ohm resistance is connected to an AC source of a 200 volt and 50 cycle per second. The value of average potential difference across the mixture will be. So 300 volt, 260 volt, 220 volt, and 0. Just move with the solution part. So for a one complete cycle, ERMS will be just 0 to t E naught sine omega t dt. So the correct answer will be 0. For a complete cycle, the value of ERMS will be 0. Next question we have. Next question we have the average EMF during the positive half cycle of an AC supply of a peak value E naught. The options we have E naught by pi, E naught by root 2 pi, E naught by 2 pi, and 2 E naught by pi. The answers we have like a fourth. So firstly we see the solution part, like how this will become. For a half cycle, E average will be integration of a 0 to t by 2 e dt divided by 0 to t by 2 dt. After integration, the result will come 2 E naught by pi. Next question we have. An alternating EMF is given by V is equals to V naught sine omega t. has a peak value 10 volt and a frequency 50 hertz. The instantaneous EMF at t is equals to 600 second is 10 volt, 5 volt, 3 volt, 5 volt and a 1 volt. Let's see the procedure part, like how this answer will become. Omega is equals to, we know, 2 pi f, and the frequency is already given here, 50 hertz. So after solution, as you know, that 100 pi k, and v is equals to v naught sine omega t. So I just put this value v naught instead of a v naught, as the question is given 10 volt is present over there. Sine omega t we just calculated, like 100 pi, and t is given over there 1 by 600. So the value is comes 10 sine pi by 6. Now pi by 6, if I just put this value of 10 pi by 6, that means this is a sine 30, and for the value of a sine 30, this value comes 1 by 2, or that's a half, and 10 and a half is equals to come 5 volt. Next question we have, the instantaneous value of a EMF and current in an AC circuit are E is equals to 1.414 sine 100 pi minus pi by 4, where I is equals to 0.707 sine 100 pi t. The impedance of the circuit will be 1 pi, 2 pi, 3 pi, root 2 pi, 1 by 2 pi. 1 ohm, 2 ohm, root 2 ohm, 1 by 2 ohm. The solution which we have, Z is equals to E naught by I naught. So Z is equals to 1 by 414, which is the value of E naught, as you can see over there, like here. And the value of I naught, this will be this. So the correct answer is a 2 ohm. Next question we have, the instantaneous value of EMF and current in an AC circuit are this and this. The admittance of the circuit will be 1 by root 2, 1 by 2 and 2. Let's see the solution part. So the mean of admittance is Z is equals to E naught by I naught. We just put this value and got the result 2 ohm, and admittance will be 1 by Z. So this will be 1 by 2 ohm. Next question we have, the instantaneous value of EMF and current in an AC circuit. E is equals to this and I is equals to, this equation is a given. The reactance of the circuit will be, again the options are root 2 ohm, 2 ohm, 1 by root 2 ohm, 1 by 2. Solution, R is equals to E naught by I naught. So we just get the result 2 ohm. And we have to ask, like, what is the reactance? So the value of a 2 ohm will be K. So the correct option will be 2. Next question we have, 12. A 220 volt 50 hertz AC supply is connected across a resistor of 50 kilo ohm. The current at time t second, assuming that it is 0 and t is equals to 0, is 4.4 sine 314t milliampere, 6.2 sine 314t milliampere, 4.4 sine 157t milliampere, 6.2 sine 157t milliampere. Just move with the procedure part, how to do. So T is equals to I naught, I is equals to I naught sine omega t, that we know. I is equals to V naught by I sine omega t. And the value of the V naught is a given, like RMS value is a given 220. So what we know, V RMS is equals to V naught by root 2. V RMS is a given 220. So the value of a V naught we can calculate from here. This will be 220 root 2. We just put this value over there and divide by R. So the resistance is a given 50 kilo. Just put all these value together, like omega t. So this will be 2 pi ft. The value of f is a given 50. So just put this value. This will becomes 100 pi t. So again If I just solve this particular equation, so get the result 6.2 sine 314 t milliampere. According to this, the correct answer is second. Next question, we have a resistance of a 20 ohm is connected to a source of alternating current rated 110 volt, 50 hertz. Then the time taken by the current to change from its maximum value to the RMS value is. These are the options. Let's move with the procedure part. This is the correct answer. So the procedure, how to solve this, that at a t is equals to 0, current is a maximum. Okay, so like I is equals to I naught cos 2 pi ft. So I is equals to I naught by root 2. This is a I value of a IRMS. Put all these value here and get the result of a t, which is a pi by 4 is equals to 100 pi t. So t is equals to 1 by 400, which will become 2.5 10 to the power minus 3 second. So the correct answer will be the one option. Next question, we have a steady potential difference of a 10 volt produces heat at the rate of X in resistor. The peak value of AC voltage which will produce heat at the rate of X by 2 in the same resistor is 5 volt, 5 root 2 volt, 10 volt and 10 root 2 volt. So just move with the procedure part. So we know that V square by R, which is actually the value of the heat, is equals to H, and there will be some changement. So V1 square by R is equals to X by 2 is given. Relate these two terms. So V1 is equals to V by root 2 comes in the nature, and V is given actually 10. So we just put is this value, like VRMS is equals to V1. So V0 is equals to root 2 times of V1. We just put the value of V1, which is a 10 by root 2. The correct answer for this question is a 10. Next question, we have an inductor of 1 Henry is connected across a 220 volt, 50 hertz supply. The peak value of a current is approximately 0.5 ampere, 0.7 ampere, 1 ampere or 1.4 ampere. Just move with the solution part. So I naught is equals to V naught by XL in the case of an inductor. What is XL? Inductive reactance. The value I just put 220 L omega, 220 and the value of the L omega. After putting all these values, the answer will become 0.7 ampere. So the correct option will be 2. Next question, we have a condenser of a capacity 1 picofarad is connected to an AC source of a 220 volt and 50 hertz frequency. The current flowing in the circuit will be 6.9 10 to the power minus 8 ampere, 6.9 ampere, 6.9 10 to the power minus 6 ampere, and the fourth one is 0. So just let's the procedure part. Let's see. So IRMS is equals to VRMS by XC, and from here XC is equals to 1 by omega C. We know the value of omega, which is a 2 pi F. So I'll just put this value of 1 by 2 pi FC. Now 1 by, I'll just given all the terms which is the present over there. Like the value of a pi is a 22 by 7. The value of the F is 50. Like that, I'll just put all these particular values. So after solution, we get IRMS by is equals to VRMS by XC. If the value of VRMS which we got, which we received 220 into 2200 divided by the value of XC, 7 10 to the power plus 12. After the solution, we got the value 6.9 10 to the power minus 8, which is our first equation, first option. The next question we have, in an LCR circuit, current is I is equals to 10 sine 100 pi t from an AC source. The value of the average voltage at the end of the resistance R is equals to 10 ohm will be the first Option 25 volt. Second 25 by root 2 volt. Third 0 volt. And a fourth one is a 1 volt. Let us see the procedure part. For a full cycle, V average is equals to 0. Hence, the correct answer is 0. Next question. In an AC circuit, EMF and current are given by the equation E is equals to 200 sine 314t and I is equals to 50 sine 314t plus pi by 3. So what is the pi by 3 represented? Phase difference. The power factor in the circuit is 1 by 4, root 3 by 4, 1 by 2, 1 by root 3. Let us see the procedure part. So we know the formula power factor is equals to cos pi. So here the value, as you know, the pi is pi by 3. That's why I put instead of a pi by 3. After solution, the result come 1 by 2. So the correct option is a 3. Next question we have. In an AC circuit, the potential difference across an inductance and resistance joined in the series are respectively 16 volt and 20 volt. The total potential difference across the circuit is 20 volt, 25.6 volt, 31.9 volt, 53.5 volt. Now, we move on the procedure part. V is equals to, we know that the value of a resultant of a V. V resultant. This will be under root VR square plus VL square. So put this values and get the result 25.6. According to that, second option is the right answer. Next question we have. An inductive coil has a resistance of 100 ohm. When an AC signal of frequency 1000 Hz is applied to a coil, the voltage leads the current by 45 degree. The inductance of the coil is 1 by 100 pi Henry, 1 by 20 pi Henry, 1 by 40 pi Henry, 1 by 60 pi Henry. Now let us see the solution. We know that tan phi is equals to XL by R is equals to XL is a what? Reactance. Okay. Inductive reactance. So we know that this value comes omega L by R. Tan 45 because angle is given over there 45. Put all these value in this formulas and get the result. L is equals to 1 by 20 pi. The second option is the right answer. Next question we have. A capacitor of 2 microfarad draws a current of 4 milliampere. When connected across an AC of a 300 Hz, the voltage drop across the capacitor is 1.06 volt, 1.5 volt, 2.1 volt and 6.6 volt. Solution part we have a VC is equals to IXC is equals to I into 1 by omega C, which is equals to I by 2 FC. From here we can calculate the value of a VC after putting all these values and get the result 1.06 volt, which is option 1. Next question we have. If the frequency of the source EMF in an AC circuit is N, the power varies with a frequency N to N, N by 2, 0. Solution we have for a one cycle, the change in EMF, power changes 2 times. So this will be 2 times of N. Next question we have a pure inductor of a self-inductance 1 Henry is connected an alternating voltage of 115 volt and a frequency 60 Hz. Then the XLP current we have these options. Now, if I'm just moving with the solution part, so we know that V naught is equals to root 2 times VRMS. That means root 2 times V naught if I just put 115. So XL is equals to omega L if I just put all these value of omega 2 pi F into L. So the value comes in the nature root 2 into 115, and for the XL 376.8 ohm. I naught will be V naught by XL, so 0.43 ampere came in the nature. According to that, the correct answer for this question is option 1. Next question we have, if the phase difference AV and AC, alternating voltage and alternating current, is a pi by 6 and the resistance in the circuit is under root 300 ohm, then the impedance of the circuit will be 25 ohm, 50 ohm, 20 ohm and 100 ohm. Now see the solution part. So phi is given pi by 6, and we know that 10 phi is equals to x by r. So 10 pi by 6 is equals to x, and our impedance is given over there under root 300. From here we can calculate the value of x, which comes 10 ohm, and the z x square plus r square. So z is equals to comes 20 ohm. According to this, the correct answer is R 20 ohm. Third option. Next question we have, a 10 ohm resistance, 5 millihenry coil of a 10 microfarad capacitor are joined in the series. So the series will be the LCR series. When a suitable frequency alternating current sources is joined to the combination, the circuit resonates. If the resistance is a half, the resonance frequency is half, double, remain same, quadrupled. So F is equals to 1 by 2 pi 1 by under root LC, which is independent of R. So this will be remain same. Next question we have, when the frequency is applied, EMF in an LCR circuit is less than the resonant frequency, then the nature of the circuit will be capacitive, resistive, inductive. Only A is true, only A and B is true, only B and C is true, A, B, C are true. So from the earlier knowledge, what we know that if omega is less than omega naught or XC is greater than XL, so only A is true. Next question we have, in the given circuit, the phase difference between the voltage across R and C is 0, pi by 2, pi, 3 pi by 2. We know that in the CR circuit, phase difference will be the pi by 2. So the correct answer will be the 2. Next question we have, in an AC circuit containing an inductance and a capacitor in series, the current is found to be maximum when the value of inductance is 0.5 Henry and the capacitance is 8 microfarad. The angular frequency of the input AC voltage must be equals to 500 radian per second, 4000 radian per second, 5 10 to the power 5 radian per second, and a 5000 radian per second. So the solution part is, when current is a maximum, the circuit will be under resonance. That is XL is equals to XC. So omega naught is equals to 1 by under root LC, and that comes 500 radian per second. So the correct answer for this question is option 1. Next question we have, figure shows that LCR circuit is connected to a variable frequency 200 volt source. The source frequency which drives the circuit at resonance is 50 Hz, 50 by pi Hz, 25 Hz, 25 by pi Hz. Solution which we have, F is equals to, we know, 1 by 2 pi under root LC. So 1 by 2 pi value, we know 22 by 7. We just put all these values and get the result 25 by pi Hz. According to that, both option is the right one. Next question we have, in an LCR circuit, the RMS voltage across R, L and C are found to be 10 volt, 10 volt and 20 volt respectively. The RMS voltage across the entire combination is 30 volt, 1 microfarad, 20 volt, 10 root 2 volt. Now let's see the solution part. The combination of a voltage is a under root of a VR square plus VL minus VC whole square. So V is equals to 10 square plus 10 minus 20 whole square. That comes the result 10 root 2 volt. According to that, the fourth option is the correct answer. Next question we have, a choke coil is a negligible resistance. The alternating potential drop across it is 20 volt and the current is a 5 milliampere. The power consumed is 220 into 5 by 1000 watt, 220 by 5 watt, 0, 2.20 into 5 watt. Move with the solution. P average is equals to ERMS, average IRMS and cos phi. So PA average is equals to ERMS, IRMS here, as cos phi is equals to 90 degrees, so the result will be 0. Accordingly, the correct option will be 3. Next question we have, the frequency at which the inductive reactance of a 2 Henry inductance will be the equal to the capacitive reactance of 4 microfarad capacitance nearly. Options are 80 Hz, 40 Hz, 60 Hz, 20 Hz. Solution we have, resonating frequency f is equals to 1 by 2 pi under root LC over there. After putting all these values, the result will come 80 Hz. According to that, the correct answer for this question is option 1. Next question we have, a condenser of 10 microfarad and an inductor of 1 Henry are connected in series with an AC source of frequency 50 Hz. The impedance of the combination will be, take pi square as a 10, 0, infinity 44.7, 5.67. So, procedure part will be, we know that the value of XL minus XC whole square gives the value of impedance. And Z for a inductor, this will be omega L minus 1 by omega C in the case of a capacitance or a capacitive reactance. This will be equals to 0. So the correct answer will be 0. Next question we have, a capacitor of 2 microfarad connected in a radio circuit. The source frequency is 1000 Hz. If the current through the capacitor branch the 2 milliampere, then the voltage across the capacitor is 0.16, 0.32 volt, 159 volt, 79.5. Solution part we have, Vc is equals to Ixc is equals to 1 by 2 pi Fc. If I'll just put all these value over there, the final result will come 0.16 volt. Hence, the correct option is the option 1. Next question is based on the transformer topic. So this is an ideal transformer has a 400 turns in the primary coil and the 200 turns in the secondary coil. If the primary coil is connected to 12 volt battery, then secondary voltage is 6 volt, 24 volt, 3 volt and 0 volt. So as you can see, the number of turns initially, this is a trick you can use also. So as you can see over there, this will be 400 turns and this will be 200 turns. So this is a step down transformer. So voltage is not 24, this is not possible. Again, the things which you have to remember, this is connected to the battery which is a DC. and transformer works only AC, not DC. So the answer will be 0. Okay. Next question we have a transformer converts 230 volt AC into 1035 volt AC. If the number of turns in the primary is 200, the number of turns in the secondary is 400 by 9, 900, 4050 and 800 by 81. So as you saw that here, the transformer convert 230 into this much large. So this is a step up transformer. This is a what? Step up transformer. And in the case of a step up transformer, if the potential of the primary is 200, so the other one is a greater than 200. So this not possible. Again, this not possible. In between both we can. So just like we see the solution. Ns by Np is equals to Vs by Vp, which if we just put all these value, so we get the result 900. According to this, the correct option for this question is 900. Hope you understand. Next question we have, the efficiency of a transformer is a 98%. The primary voltage and the current are 200 volt and 6 ampere. If the secondary voltage is 100 volt, the secondary current is 11.76 ampere, 12.25 ampere, 3.06 ampere and 2.94 ampere. So if I'm just moving with the solution part, we know efficiency formula Vs Is by Vp Ip. After putting all these values, we get the value of Is, which is 11.76 ampere. Option 1. Moving with the next question. In a transformer in which the loss may be neglected, the ratio of the primary voltage to the secondary voltage is found to be 4:1. The ratio of the primary to the secondary turns and the ratio of a primary current to the secondary current are 4:1, 1:4, 1:4, 4:1, 4:1, 4:1 and 1:4, 1:4. Just move with the solution part. So Np by Ns is equals to Vp by Vs is equals to Is by Ip. Ip by Is is equals to Vs by Vp, which is a 1/4. So according to that, the correct option is a 1. Next question we have a 39. The transformer ratio of a transformer is 10:1. The current in the primary circuit, if the secondary required 100 ampere, assuming the transformer as an ideal situation, that will be 500, 200, 1000 or 2000. Just use the formula of Np by Ns is equals to Vs by Vp is equals to Ip by Is. So I'll just put all these formula over there and get the result of Ip, which is 1000. The correct option will be the 3. Next and the last question we have, the transformation ratio of a transformer is a 5 if the primary voltage of the transformer is a 400 volt, 50 hertz, secondary voltage and the frequency will be 2000 to 50 hertz, 80 volt, 50 hertz, 80 volt, 10 hertz, 2000 volt, 50 hertz. Process we have the same formula, Ns by Np is equals to Vs by Vp. I'll just put all this particular term and get the result. Vs is equals to 2000 volt and frequency remains constant, that is a 50. So the correct option will be 4. This is all for today's class, student. I hope you enjoyed the class and did the very important questions. So thank you for watching this video. Take care.